created automatically in your storage account. That's why we need a storage account. And then this orchestrator function, it can be unloaded from the memory, and we stop paying for this. And at the same time, activity function gets triggered by this message in the work items queue. And it does the processing, and then it puts the result to control queue, which wakes up the orchestrator function. Then orchestrator function goes further with the process and put another work item message to work item queue and goes sleep. Activity function processes, control, blah, blah. Yes, clear. But the question is, if our orchestrator function constantly got killed and sometimes it is unloaded from the memory, how does it work? Because it needs to restore the state. Because as you remember, we have in the beginning what we do, we load first the image from the storage, then we run first activity function that calculates how many times we can downscale it, and then it goes. It dies, it sleeps. Then activity functions, it returns the execution back. And then how it knows that we already have the results and goes further. So it needs to restore the state somehow. Under the hood, the orchestrator function uses the event sourcing technique, which is called checkpoint replay. Every time orchestrator function calls an activity, it stays checkpointed into history table under your storage account. When activity function is finished, a history is replayed to rebuild the state of orchestrator function. Since orchestrator and activities may be run on different VMs, in some environment that is not 100% reliable, this approach gives guarantees reliability actually. And yes, and however, this replay process is reliable, but it leads to some interesting behavior. Let me show on some example with these two funny characters, and just I couldn't find something more mature. Let's practice. Let's let them practice in origami, and ask them to make a plan in a Azure Durable Functions way. So let's say that one of them is orchestrator and another one is activity. That's the reaction, like someone's happy to be orchestrated. And okay, we have this kind of a program. This is orchestrator going to execute this, and all the folding operation going to execute activity. So what happens? Orchestrator encounters the first folding action and calls activity to perform this step. And activity agrees, orchestrator goes to sleep, then activity finishes this task, returns the results to orchestrator via the message in the queue. Then orchestrator wakes up and replies the history to restore the state. So it looks like it asks an activity to perform this first step again. And then, since we already have done this, results are captured, activity is not called. The orchestrator moves further forward with the execution and asks activity to perform the second step. Activity agrees, orchestrator kind of sleeps, then activity finishes with results, gives it back to orchestrator wakes up and says, okay, let's do it again, let's perform the first step. Activity says, no, it's done. And then, okay, then perform the second step. And it's also already done. Results are captured, activity says it's done. Like, then orchestrator asks to do the first step. Activity is kind of agrees, doing the first step, finish it. Orchestrator wakes up, start from the beginning. Let's build the first step. That is done, and it can go just like continuously. It's like the house that Jack built, and realizing the fact that the state is always replied in this way is very important to avoid some stupid performance issues. If you wonder how it affects performance, let me convert this example into like with this 6 chained fault actions into code. So we could have this kind of activities called 6 times with fault. So what do you think? How many times how many times this method will be called? Any idea? Not actually the execution will happen, but how many times we will this exactly that's the arithmetic progression. So it's like 21 times for only loop with the 6 iterations. So this is the plot that shows how this increases, and this is fine when we have this kind of code, but it becomes the performance started to suck when we see this kind of code. So we do something heavy and then we call the activity. So it means that activity actually will be called exactly the 6 times, but this heavy operation will be called 21 times. And that's why we should perform every heavy processing inside the activity functions. So, but now we probably can answer the question why it was not deterministic. Because if we look back into to my code, we can see that we load the image from the container, from the blob storage, and we scale it down, and we store it. So basically, this scaling down will happen not that amount of times that we calculated for levels, but it will be calculated way more times. And also the cropping will happen probably the first time, but next time it will go here. The cropping is not needed because the image already cropped here. Yeah, so there are some constraints to use the durable functions. Since it will be replied multiple times, it shouldn't it should produce the same result each time. No direct calls to get date, time, generate random numbers, random GUIDs, or call to remote endpoints. And another one, the asynchronous calls. Durable task framework execute orchestrator code on a single thread. And that's why it cannot interact with other threads. That's why we had these issues with asynchronous call. And since all the history of executions is saved into a table and it restores constantly the state, if we have infinite loop, it will end up in out of memory